Hello from the road trip with another exclusive Optica episode of featured interviews we are releasing this summer. It's all designed to trigger important discussion points for the Global Photonics Economic Forum in Malaga, Spain on October 1st and 2nd. Remember when photonics was difficult for politicians to say?
Today I'm announcing a $100 million competition to create a new hub around Photonics. I had to ask Penny to make sure I pronounced it right.
It's amazing to recall that 2 years ago, on July 28th, the US Congress passed the CHIPS and Science Act, a $280 billion package that includes $52 billion in funding for companies that manufacture semiconductor chips in the USA, including Intel. The same act allocates a further $200 billion for scientific research into artificial intelligence, robotics, quantum computing, and other cutting-edge fields. As President Joe Biden steps aside to make way for Kamala Harris, we will be closely monitoring the success of those investments in Semicon and its effects in photonics.
I think this facility and the folks who are here embody the best of what Minnesota has to offer.
We're here at Polar Semiconductor. It's a microchip manufacturing company right here in Bloomington, and we're here to celebrate the announcement that they're receiving $120 million as part of the CHIPS and Science Act funding from the federal government to expand this entire operation.
Meanwhile, in Europe, a similar CHIPS Act is now law in 27 countries. A much smaller $43 billion of policy-driven investment will support the European CHIPS Act until 2030, which will be broadly matched by long-term private investment. But now we know only $340 million is set aside at the moment for direct investment in photonics. So let's look at how some of that money is spent. For my next summer safari, I took the slow train from Brussels and then a €100 Uber ride to a suburb of the village of Gooik. Our destination is the Photonics Innovation Center run by Free University of Brussels, VUB. Its founder, Hugo Timpont, is well known for his pioneering work in establishing ACMOST, ACFast, and Photon Hub Europe. He has a clear practical vision of why Europe should invest more in photonics. I got up very early this morning, coming from Brussels to Gooik to visit, and it was about time, to visit the Vrije Universiteit Brussels Photonics Innovation Center. Where am I right now?
Well, right now you are in Gooik, in actually the middle of nowhere, beautiful countryside, and we needed that quiet place in order to put down our Photonics Innovation Center and to host all our extreme equipment for the manufacturing of freeform optics, therefore our freeform optics pilot line.
So this is a center for prototyping and series production of freeform optics.
This is a center for both the design, the prototyping, the upscaling, the testing, and if needed, the mass manufacturing of freeform optics, both in polymers and glass.
What problem are you solving for the industry?
Oh, we are solving quite a lot of problems for industry. Whenever industry has a challenge, an optical challenge, we listen to the companies and then we are trying to solve their problem with the most adequate technologies. We don't do a technology push. We listen to the challenges and then find the best people, the best teams and the best technology platforms to help them out.
Freeform optics are mature now to solve technology problems.
There's a lot of freeform optics that becomes mature. It's, in my opinion, not fully mature. There are a lot of challenges in the design, the measurements, very difficult, and then the upscaling. If freeform optics fabricating one component can be quite expensive. So the challenge is also to make sure we can put that on the market at very low cost. And at that moment, it will revolutionize optics.
You are collaborating with many companies for many years in the industry, from ACMOST, ACFast, ACFast 4.0, Photon Hub. Here you are serving the industry. Which companies should care about this center?
I think all companies that want to innovate their products with optics and with photonics should care about this center. Whenever somebody would really like to innovate, create additional functionalities, improve the specifications, they should contact us. It's very simple. We are trying to lower the thresholds for innovation, both financially and technologically. And we do that with European projects like Photon Hub.
You're going to show me around a little bit. What am I going to see?
Oh, what you're going to see? You're going to see, first of all, our design center, and then you're going to see our pilot line machine rooms and our testing quality measurement center in clean room conditions, and then our demonstration labs and a demo center. Because we're trying to now elaborate a demo center where we can show industry what photonics can do for them.
Thank you very much for having me. Okay, let's go see it.
Thank you, Jose.
So let's explore the campus. 1, 2, 3, 1, 2, 3. We continue our visit and we are right now at the clean room.
Yes,
At the clean room.
Photonics Innovation Center of VUB in Gooik. And I'm trying to present the confocal fluorescence microscope from Leica. So this system is one of the best state-of-the-art devices currently. We have a system which has 2 lasers, one at 405 and one visible supercontinuum, so from 470 to 670 nanometers. And this system allows at the same time to get up to 8 lasers working together. So you can take, for example, a cell stained with different dyes of different excitation wavelengths and do sequence measurement with different lasers, put together the images, like you can see even here. So I have a cell, I did imaging, and I could put them together to see the whole picture of the cell, whether they are live, dead, there are lipids present, and so on and so on. The system is also equipped with 4 detectors. We are like PMTs, standard PMTs, and also hybrid detectors, which are from Leica. So the PMT, it works like 1 creates 2, 2 creates 4, 4 creates 8, and so on, right? But instead, this hybrid detector is from 1 photon, it immediately gets avalanche photons, so it's a higher resolution.
What are the main applications we are using this for?
We are using it for cell research, actually, for bio applications. But also we have some polarizers, analyzers, so we can also study anisotropic materials. So it's a great tool to do bio research, basically. And
because many people know this center because they work in freeform optics, but what I'm seeing is that there is a lot more going on here.
We're doing a lot of bio research, integrated photonics, laser studies, and actually we are now also doing a lot of research in 3D polymer fabrication based on 2-photon polymerization, actually.
The VUB is a leader on freeform optics manufacturing. Jürgen van Erps explains to us how it's done.
A heavy-duty spindle for large material removal, and then we have a high-speed spindle which can do already some fine finishing of the part. It's not yet optical quality, but it's already very close to the final shape that we can then further process either through polishing or through diamond tooling finishing.
These kind of tools that we have here, we rarely see, or I have never seen them at R&D or research-oriented facilities. What is the purpose of owning this manufacturing equipment?
Yeah, so we try to do as much as possible of the entire chain in-house in order to have good control of the lead times for the different components. So when we are finished with this kind of pre-shaping, then the real work starts, and that's where we want to get it to optical quality. And previously we were doing this pre-shaping through subcontracting, but it's important to have as much as possible in-house to make sure that you comply with the specifications and to keep control of the lead times.
This is a high accurate machine.
Yes, so we have about 10 micron accuracy of the machine. So it allows us to get really close to the final shape. And then we either do a polishing application on this, or if we want to do diamond tooling, we typically apply a layer of nickel phosphor coating, and then we can diamond tool the phosphor. We have a fast tool servo head. We will be having laser assisted and ultrasonic assisted diamond tooling soon as well. So in this case, we can finish mold materials in metal that have been nickel phosphor coated, or we can also do direct prototyping in polymers, for example, or in specialty materials like zinc sulfide, calcium fluoride,
So
germanium.
it is not the goal to get prototypes for nanoscribe and then manufacturing them here for volume. These are different accuracies and different technologies.
Yes, in most cases, although we did also some glazed gratings, mold making with diamond tooling that have then been used in replication processes. And then afterwards, we finished the mold with diamond tooling, and finally you get to this kind of finish. The colors that you see are, of course, the coating that is applied on the sample. So this is something that has been done after we have finished the in-house production, let's say. But as you can see, we can either do small series with hot embossing, or we can go towards larger series with injection molding. And depending on the size of the component, we would either go for a micro-injection molding application. So in fact, what you see here is a very small part with an array of 8 micro lenses with a 45-degree mirror.
Optica ambassador Tate Chalian explains to me that they are planning to expand.
So basically, we will be expanding towards there.
Yeah.
Will be big. So this Photonics Innovation Center, big. 1, 2, 3. So 1 is the initial one, where the meeting room was. Then 2 is the offices. The 3 is the labs.
Yeah.
We will have 4 and 5, 6 here. So it will be completely expanded towards there. Here we have the crew house, crew town. So this is actually also the land, the green part there, is for our activities for kids.
Yeah.
So they are coming here to do smart housing, engineering, like from 8 years old, I think. In summer they have summer camps right there. And my sister is actually doing because she is an outreach officer.
And the last person we met was Jan Vate, very well known by his time at Comscope. But what does he do now?
So my job is I'm a business coach for Photon Hub. So Photon Hub is a European program that is running now already for a couple of years, and where we try to provide support to SMEs and also companies that want to do something in photonics. That's quite challenging because there's a very versatile application scope for implementing photonics in industries. For instance, also in agriculture. And the challenge there is that companies are not fully aware of what the potential of photonics technology is for their business, that we should bridge the gap and that we make them aware of technology that is very interesting for them and that could really propel their business.
Getting hundreds of non-photonics companies to use photonics for solving their technology bottlenecks is the goal and has been the success of Photon Hub. But you want to go the extra mile. You want to attract new companies, solve new challenges. What's your strategy on that?
Well, the strategy is that we will not particularly focus on one particular technology. So we can provide expertise in freeform optics. We can provide expertise in integrated optics and not in particularly in one platform. Now the challenge there is, of course, a company who wants to do something with integrated photonics will never reach let's say the target from the very beginning. And the challenging thing is there already that they can, with the help of Photon Hub, demonstrate that the chip that they want to commercialize is working. But we go a little bit also the extra mile later on. They can come back and they want to scale up. We can go then for a follow-up program in order that they can show their market readiness and that they mitigate a little bit the risk and make sure that then they will do a successful market entry.
I'm sure you're going to do a fantastic job. The experience that you bring from the real industry, volume production of photonic devices industry is of a major value for Photon Hub. Great to see you again. Wow, it was an amazing experience to visit VUB 23 years after I studied there. Now, time to go to my next stop.